Okay, so looking at homework 5, this is the second part of the high school science achievement work that we did for homework 4. This time we're going to add the interaction term. So I'm going to scroll down here to question 1. So the first one is just telling you which analysis to run. So this time I'm saying run a GLM, ANOVA, or regression analysis to address the research question posed by your advisor, which means they're looking for an interaction. They're talking about an interaction between gender and reading score in predicting science. So next here we have the question 2, which is please interpret the results of your analysis. So I'm looking for interpreting the R squared, which you should have gotten from the output file. Does anyone here have it pulled up and can tell me what R squared says? 49%. R squared equals 49%, which means by our predictors. So now I say the intercept and all 3 slopes. And I say that because we'll get an intercept value, and then you'll have a slope for the first predictor, which is reading, a slope for another predictor of gender identity, and a slope for the third predictor, which is the interaction between gender identity and reading. So can I get some slopes? Somebody at home, somebody on the Zoom, unmute for a second and tell me a slope or an intercept. I'll take any of those. Or I'm going to start drawing random names.
1.123.
Which is what? 1.123?
Negative 1.123 for gender equals 0.
Tell me, is this is the gender slope? Which slope is this?
This is gender.
For gender? Sorry, you just broke up a little bit there, Sarah, so I wasn't quite sure what you were saying. So I think you're saying the slope for gender was negative 1.123. So then somebody else on Zoom, give me another slope. Give me the slope for reading or the intercept.
For reading, I got 0.63.
It's pretty close to our 0.66 it was last time. Okay, who else do we have here? I think we have Tiffany. Can you give me an intercept or this slope?
The slope is 0.063.
This slope.
No, she's the interaction 0.063.
Oh my gosh. My goodness gracious, I am sorry. That is extremely confusing. All right, great, thank you. Somebody in the room, can you give me the intercept? 0.96. Okay, so these are our answers. Now when I say interpret them, I mean like this. So here's my first interpretation. This R squared of 0.49 is 49% of the variance is accounted for by our predictors, or more specifically by reading and gender. Variance in science is accounted for by our predictors, which is reading and gender and the interaction between reading and gender. All right, the intercept.
When the T-score is 0, holding gender constant, then science T-score is 18.096.
You're very close. When reading is 0 is correct, and when gender It's not holding gender constant now because we have an interaction in the model. How can we say that? And what's another way you can say that?
Gender would be 0, so that I believe was females.
Yes. The difference is that once an interaction is in the model, remember we talked about how if your main effect there, your intercept is only valid for that exact point because those lines are all over the place depending on where you're interpreting things. So for females with a score of 0 on reading, their expected science score is 18.09.
Isn't male coded by 0?
Yes, I think maybe Sarah does too. Sarah, you want to say that again?
Yeah, so I was questioning why when gender is 0, that's females, because male is coded as 0.
That's a good point. I think it depends on what your output looks like.
Yeah, I think it was zeroed out on females, but in data, males were coded as 0.
Aha. So if you're looking at the output and the output has a 0 next to one of those two, that means that's the one that we're interpreting the intercept on.
Dr. Lynn, I'm gonna need you to repeat that.
Yeah. Tell you what, why don't I run it?
I'm trying to pull up my output, that way I can have a point of reference.
That would be great. I think pulling up your output is the way to go, which I think I asked you to put the output in your write-up. Did I ask you to do that? Just the syntax, okay. Usually I ask for output, but that's when you're doing your own analyses. So let me pull this up and we'll run it real fast. GLM2. All right, here's my HSB4 from homework 4. All right, so the question that we have is, if you don't have your output available, take a look at your syntax and let's compare them. The question is, do reading and gender and their interaction predict science score? So, I think I can remember the code. Let's see. Did anyone use by? Is it model? No. Design. I need gender. I need the main effect of gender. I need the main effect of reading. And then I need the interaction.
Can you check me in the syntax? Does the capitalization of the variable names matter?
No. In SPSS, it is agnostic to the case of your variables. If you are using R, it is extremely sensitive to the case of your variables.
Brady's not there.
So if you're working in R, you have to pay close attention to that. But here, it doesn't matter. You can switch back and forth. So now I've run that. And let's take a look. Looks like we have 273 males, 327 females. Here's my total model. My R squared here is 0.4888, so that would be like 0.49, which matches up to what we just said. I'm going to take this guy. I'm going to put it over here.
Are you recording?
I am recording. I am recording just for you. It's tiny right there. Recording on this computer. My poor computer is very full. Okay, now, what am I doing over here? We're typing it into this Word document. Homework. Why? Get out of my gosh. Okay, well, we'll just try our best. So here we have 18.096. So that is when gender equals 1 is 0, which is very unfortunate, which means that what was gender equal 1? Gender equals 1 is female, so yes, 4 females. Let me do it a different way just to show you. I'll do it afterwards though. Let's finish with this interpretation and then I'll do it again. So, folks at home, if you want to talk, just unmute and say something because I'm having a hard time keeping all the screens going at once. So just pops. Oh, wait. Oh, I forgot. Guys, I made you, just for you, I made you a discussion for today with the idea that I'm trying to really embrace a little bit more the fact that half of you are at home and half of you are in the room. So here on Carmen, you can just, if weird things come up, or maybe consider this to be like a group notes page, or if you have questions that come up as we're talking, hop on here and write them down there as well. And that will keep a record of it that will stay after we close the Zoom. I hope. And then Susan, because you're in there, I unfortunately didn't think about this in time to actually ask you about this, but if you can monitor that, that would be awesome. And make sure that we're getting everybody answered. Okay, back to this. Alrighty, so now we have a slope for gender, negative 1.123. Does anyone feel pretty confident about their response and want to go ahead and say it out loud?
I'm not confident that I can say that.
Yeah. Well, you've already done one, so now it's somebody else's turn.
We would expect males with a reading score of 0 to score 1.123 points lower than females in their test.
Lower than. Did I say it all? We would expect that males with a reading score of 0 would score 1.123 points lower than females with a reading score of 0. Okay, so that we get because this is negative 1.123, and that's going from 1 to 0, moves you down by 1 point. So that's going from female to male. So males are scoring 1 point lower. That's where that comes from. And yes, key here is saying reading score of 0 for both, because remember, we're only interpreting it at the 1 point. So now for reading, calling on random people is so much easier when everybody's together, because then I can just pull the number out of a hat. Okay, let's do, can someone else speak up on who's on the computer here about the reading interpretation?
For everyone, is readings. Science scores increase significantly by 0.
By 0.63, and I think you said something else and I missed it, so can you fix this for me?
For females,
Yes, for females. Every 1 point difference in reading, science score increases significantly by 0.63. Yes, exactly. Because remember, we were drawing those two different lines last time. We're only talking about one of those two lines, the slope of one of those lines. Now, this one's the tricky one. Anybody feel really good about their interaction here for gender times reading? Yep. Reading score and science. What was the p-value? .26 something. Okay. P equals 0.267. Okay, so there we have that. So those are all of our interpretations. And next, I said pick 2 points on the two x variables. Say girls with a low reading score or boys with a low reading score or girls with a high reading score, picking a couple of these points, and then calculate the expected scores for each. Describe what the low and high reading scores are that you've picked using descriptive statistics. So for this, I assume, Sarah, was this the one that you were confused about?
Yes, I did not know what it was asking.
So anybody want to talk to me about how they approached this question?
I wrote out the formula, and then I looked at the descriptives, and I used the mean scores for reading for my X2. And I used, so actually this is one part that I'm unsure about. So I used 1 for X1, assuming 1 was female. But if the UniAnova flips it around, do I flip it around here, or do I use the original coding?
If the UniAnova, let's look. Let's look. Wait, let me answer that first after we talk through this. So you read out the formula, you looked at the descriptives and used the mean scores for reading. Now, what did you mean by, was the mean score for reading, that was one of the points that you picked?
Yeah, that was one of the points that I picked. The second point for X1 was 1.
Uh-huh, okay, that makes sense. So you picked the mean and said, I picked the mean.
Yeah.
That's a totally valid thing to do. So here I was just saying, pick 2 points. I don't care what they are, just tell me what they are.
And then I just plugged them into the formula.
Mm-hmm. Okay, did anybody else do this differently? There's more than one right way to do this. Yeah, go ahead.
I calculated the minimum and the maximum using descriptives again. So I calculated for a reading score of 28 and a reading score of 76.
Okay, so you picked the minimum and the maximum. Min is 28 and the max was 76. Did you use male or female or neither or both?
I thought you meant do that for both males and females, so I did all 4.
Awesome. That will give us a really good idea of how that interaction manifests. You can see how the slopes of the line will be different if you do it with all 4 points. Anyone else do something different they want to talk about? Does anyone else do something different than this and would be willing to share it so that their classmates can hear one other method of approaching this question? No one else? The only other way I would say that comes to mind immediately would be the mean and then 1 standard deviation above the mean, something like that. Whoops. Okay. So that gives you a little bit of an idea of what's going on in the data. And then I just said, give me your code and SPSS syntax. So now that I've done that, let's go back to your question about what do I plug in? So let's look at the output. So if you want to know what the expected score is for females, you know right now that all of these values are already talking about females. So you don't need to plug anything in. But if we're talking about males, then you would need to plug it in. And unfortunately, it looks like you plug it in as 1. So yes, you have to reverse them in order to get the score for males. However, let's do it the other way. With gender and reading. Now that I've done it like this, because our gender is coded as 0 and 1, we're going to trick the program, and it's going to not know that this is categorical and is going to treat it as if it's continuous, but the math is still the same. And so you'll see this is identical. We still have 3 degrees of freedom in the numerator. Our R squared is 0.49. Now, a couple of things are different here. I'm going to try to show you these side by side. Ha! Nailed it. So that we can look at these. It's kind of hard to read. It's pretty small, but here the intercept that most of you got for your homework was 18.096. Now the intercept is 16.973. Why is it different?
Because now it's telling us what, the predicted science score is for females. Reading score 0 instead of males.
Wasn't it females before?
Oh, yeah, just kidding. Have it backwards.
Yeah. So now it's telling us the expected score for males. Because males are coded as 0 in the data. So instead of running it with I'll paste the actual syntax in here in a minute, and then I'll post this online for you. Because it's telling us what the expected science score is for males now, our intercept is different. What about this one? Is this different? Gender is 1.123. It reversed the sign. And why is the sign reversed? We flipped which one was 0 and which was 1. So the coefficient is now interpreted the other way. Signs? Sure. What about B2? Is it the same or is it different? B2 is reading. Somebody at home, is it the same or is it different? Uh-oh. It is the same. Is it identically the same? Yeah, it's the same because our rounding rounds it to the same, but it's kind of different, which is very strange. 6, 9, 2. It's almost the same. 0.69 now, and before it was 0.63. So it's not quite the same. Do you see this one for reading? 0.692. And that has changed because before we had the slope for females, and now we have the slope for males. Does that make sense, folks at home? Can I get a say what? Or can I get a, oh, okay. Thank you. All right, I'm going to move on then. So now we've changed what that is. What about this one? Now let's look at the interaction term. The interaction term before was 0.063 and the p-value was 0.267. Has that one changed? Ah. Sorry, guys. Yeah, it's changed sign, but otherwise it's the same. And the sign changed for the same reason that the sign changed before. It's because we changed what 0 means. Okay. That's it. Those are all the possible responses here. So in both cases, you interpret them substantively the same way. We still find that males and females are different, and we always find that the same group has an advantage compared to the other group. It's just that how we interpret that number depends on how the program or we have coded 0. Which is why this is a very common error that people have to retract from their publications sometimes, because they don't pay close enough attention to it.
Can you show us the syntax thing?
Yes. There are the two different ones. What you'll see is that with this one, all I did was move this, instead of saying by gender, I've moved it into the with gender. But the rest of this is the same. So here I'm going to put the code. So if we use this as our code, then this is the result. And if we use this as the code, then this is the result. Okay? Excellent, thank you. Okay, other questions on the homework assignment before I save this and put it away for later? Okay.
Oh yeah, just a simple question.
Uh-huh.
How, if we want to view this graphically, how do we do that?
If we want to do it graphically, how do we do that? I'm so glad you asked. We do it with the equation. Let's use this equation, and we do it with Excel. Don't look at that, because that's the answers to a quiz later. Okay, we're going to need values for males and females. And because here, I'm going to use this equation. It tells us male is 0. So I'm going to put the numeric representation of that here, and female is 1. And then for the reading, I'm going to pick a couple of values for what reading could possibly be. Who remembers what the descriptives are for reading? Does anybody know? You literally just told me 20 and 76. Okay, 28, got it. All right, so we already have a minimum and a maximum. So now we plug in the equation. So we're going to say y, because we're getting an expected score here, equals 16.973 plus this gender coefficient here is 1.123 times whatever the value is in this gender column. And I don't want that to change, so I'm going to use, I want it to move. So I'm going to use that, and then I'm going to add in the next coefficient, which is 0.692. 0.692 times, this is for reading, so I need to go over here for the value of reading. I'm going to click there. And then I'm going to do my interaction term, which is negative 0.063 plus negative 0.063 times this here. Hello. And again times this right here. Close parentheses. There's my whole equation. That's my expected score for a male with a reading score of 28. And now because of how I typed this formula, I can just copy and paste it right over, and you'll see that all my references moved. So here's the expected score when reading is 28 for females. They are not very different at all. And here's my expected score when reading is 76 for males, and when reading is 76 for females. Now to graph it, guys, I love Excel. Done, graphed. So take a look here. These are the most extreme values. You can't see what's going on necessarily because nothing is really labeled, but we can add these labels a couple of ways. Give me all the labels. Oh my gosh. Oh, I don't want style. I want like layout. Where's my axis titles? Okay. So here, this is our expected score. So this is science. So across this axis here, we only have two values, but the two values are, well, they should be, should be reading, but I can't tell if they are right now. Aha, they're not, so let's switch it. So what I'm going to do now is, because I want this line to represent the continuous variable, the slope of this line to represent the continuous variable, so what you can do is tell it to switch what the rows and columns are. Now there are my two slopes. I'm going to click select data so that I can get more information about the horizontal axis category. I think I did that wrong. Yeah. There we go. So now we have, this is for 28 on reading, and this is for 76 on reading. You'll see that down here, they're very, very close together. And up here, they're a little bit farther apart, which is that interaction manifesting. But they are still like pretty parallel, these lines are. And we think that these lines are probably parallel. Why? Why do we think they look parallel? Correct, because the interaction term was not statistically significant. I'm going to also add a title. And I'm going to, because that will help us with our understanding of what's going on in this graph. Okay, there's the answer for the homework that we did this week. Graphs. Okay. Other questions, folks? I'm going to stop this.